All right, this is Unit 7, Day 8 notes, expected value and fairness. Basically, we're going to be taking like different situations and find the probability and then using that probability to find out if you, like for example, how much money you would win or what's the likelihood of drawing a certain item a certain amount of times, that type of thing. So like for example, we have 4 red marbles, 2 blue marbles, 1 white marble, and 5 orange marbles. If I pull a marble 10 times and return them each time, how many times will you pull a blue marble? So first of all, we have 4, 5, 6, 7 marbles. No, so 4, 5, 6, 7, 8, 9, 10, 11, 12 marbles total, because we also have 5 orange marbles. So we have 12 marbles total, and we have 2 blue marbles. And we want to know if I roll that, or if I pull out a marble 10 times, how many times am I going to pull out a blue one? Okay, so what we do is we take that probability, 2 out of 12, and we multiply it, the whole entire thing, by 10. Okay, so all you gotta do in your calculator is do 10 times 2 twelfths. Make sure you put the whole fraction in parentheses, and that gives you 1.667. Okay, and so what that means is you're obviously not going to pull 1.6 of a decimal or 1.6 of a marble out, but it's saying basically that you're going to pick anywhere between 1 and 2 marbles out if you pick it 10 times. So that's the likelihood of pulling a blue marble. Okay, so for number 2, say you want to draw 1 card from a standard deck of playing cards. Okay, remember we talked about cards has 52 cards total. Okay. If you pick a heart, you will win $10. So remember, there was hearts, clubs, spades, and diamonds. So with hearts, there is 13 out of 52 cards. Okay, and it says you will win $10. So we're going to take that fraction and multiply it by 10, but I'm not going to do that yet. Okay, so if you pick a face card, which is not a heart, you win $8. So remember, a face card is king, queen, or jack. Okay, but it can't be a heart. So that means we have spades, clubs, and diamonds. Spade, club, and diamond. So that means we have king, queen, jack for all 3 of these. So that's 3, 6, 9 different cards out of 52 total that are a face card that are not a heart. And you win, it says you win $8. So we're going to multiply that by 8. All right? And then it says if you pick any other card, you lose $6. So that means if we take 52 cards and we subtract 13 and 9, that gives me 30 cards. So that means I have 30 cards left out of 52. It says if you pick any other card, you lose $6. So that means I'm going to put a -6 outside of that 30 over 52. All right, and what you do is you take all 3 of those possibilities and you add them together. So we're going to do 10 times 13 over 52 plus 8 times 9 over 52 plus -6 times 30 over 52. And that gives us a total of 0.42 and so on and so forth. We're talking about money, so that we have 2 decimal places. All right, so that means, so whenever this is talking about this, and this is where the fairness comes into play, if you were to have done all this and you got a negative number, that means you're most likely going to be losing money when you play this game. If you had gotten 0, that means it's a fair game. There's a possibility you could either win or lose, so there's any possibility could happen. But if it's positive, so we got positive 42 cents, that means it's fair because there's it's more than fair because it goes towards the player's option because they are more likely to win money from this game versus lose it. So yes, this is fair because it's over 0. Anytime it's over 0, that's honestly more than fair for you. Okay. All right. Example 3 says we have a famous gambler from Philadelphia, Senor Rick. And he proposes the following game of chance. You roll a fair die. If you roll a 1, then Senor Rick pays you $25. So if you roll a 1, and you're rolling a dice, okay? So if you roll a 1, he pays you $25. So that means And remember, remember a dice is 1, 2, 3, 4, 5, 6. So that's 1 out of 6 chances that you're going to roll a 1. And you get $25 out of that. So I'm going to put 25 outside of there. All right. If you roll a 2, so if we roll a 2, he pays you $5. And again, 2 only happens 1 out of 6 times. And he's going to pay you $5. If you roll a 3, you win nothing. So 3... that's 1 out of 6 chances that a 3 can happen. You win nothing, so we put a 0 out front of there. All right? If you roll a 4 or 5, okay, and 4 or 5, that's 2 different possibilities out of 6 total. 4 or 5, you must pay Senor Rick $10. So I'm going to lose $10. You can either put plus -10 or just put -10. And if you roll a 6... So a 6 is, again, it's going to happen 1 out of 6 times. You must pay Senor Rick $15. So minus 15 outside of that fraction. Okay. Is Senor Rick loco for proposing such a game? And explain. All right. So we've set up our problem. Now we need to plug that into the calculator. So we got 25 times 1 out of 6 plus 5 times 1 out of 6 plus 0 times 1 out of 6 minus 10 times 2 out of 6, minus 15 times 1 out of 6. And so that means negative 0.833, okay? So what that means is, or negative 0.83, we could also stop at the 2 decimal places. Now it's asking us, is Senor Rick loco for proposing such a game? Now we're not talking about from our perspective, because from our perspective, obviously, we don't want to play this game because we're going to lose money. But in Senor Rick's side, he's going to be gaining that money every time. So no, he's not crazy. He will gain money. Now, if the question asks us if we were loco for playing the game, the answer would be yes, because we're going to be losing money every time we play the game. Okay? Or you're most likely going to lose money. All right, number 4 says you pay $10 to play the following game of chance. Okay, you pay $10. There's a bag containing 12 balls. 5 are red, 3 are green, and the rest are yellow. And so out of 12 balls, 12 minus 5 and 3 gives us 4 yellow left over. Okay? You are to draw 1 ball from the bag. You win $14 if you draw a red ball. Okay? Now here's where you have to be careful here. Because originally, if you pull a red, you get $14. But I had to pay 10 at the beginning to even play the game. So really, I'm only gaining $4 when I draw a red. So that's going to be 4 times 5 out of 12, because there's 5 red out of 12 marbles total, and we're going to win $4. All right, it says, and you will win $12 if you draw a yellow. So again, when we win $12, we have to subtract that 10 out, so we're really only winning $2. All right, so that becomes 2 times 4 out of 12, because that's how much money we're winning. 4 is how many yellow marbles we have out of 12 marbles total. All right, and it says nothing about green, so that means it's assumed that you're going to not win anything if you get 3 out of 12 marbles for our green. So if you get a green, you don't get anything. All right, it says, how much do you expect to win or lose if you play this game 100 times? Well, first of all, we got to find out what it's going to be if we play 1 time. All right, so we'll take that 4 times 5 over 12 plus 0 times 3 over 12 plus 2 times 4 over 12. And that gives us 2, did I type that in the calculator wrong? 4 times 5 over 12, 0 times 3, forgot. With the green, we start out, we don't win anything, but we also had to pay $10 to play. So that's actually negative $10. So if you get a green, you technically lose $10. So it's minus 10 there. My bad, almost forgot that. So let's change that. 4 times 5 over 12 minus 10 times 3 over 12 plus 2 times 4 over 12. There we go. So that means if I play one time, I'm going to lose negative 16 cents or negative 17 cents. Okay? Now say I want to play 100 times. Okay? So what you do is you take that answer we just got and we multiply it by 100. And your answer might be a little bit different than mine if you round it to 0.16 or 0.17, or if you keep the way it is right there. So if we keep this, that means we're going to lose negative $16, or we're going to just lose $16.66. We're going to lose that much money if we play 100 times. So we definitely don't want to play this game, because in the end, we're going to lose money no matter how many times we play. Now, you might get lucky and things are changing, but based on the probability and the math of the whole thing, you're most likely going to lose. All right, so that's questions 1 through 4. I'm going to flip over to the next page. We got 3 more questions to put. All right, so we have a game that you flip a coin twice and record the number of heads that occur. You get 10 points for 2 heads, 0 points for 1 head, and 5 points for no heads. What is the expected value of the number of points you will win per turn? Well, first of all, we need to find out what type of ways we can win, or what type of options we have. So you have the option where you get 2 tails. You have a tails and a head, or a head and a tail. Oops, head and a tail, or 2 heads. Okay, these are the 4 different options that's possible to happen. All right, so it says you get 10 points for 2 heads. Okay, so for 2 heads, that's the only one option here. Okay, so that's 1 out of 4 options there. So 1 out of 4, you get 10 points. You get 0 points for 1 head. So that's these 2 right here. They only have 1 head. So that means plus 0 for 2 out of 4 possibilities. And 5 points for no head. So that's that tails right there. So that's plus 5 for 1 out of 4. Okay? And so we play that and says, what is the expected value for the number of points you will earn per turn? So 10 times 1/4 plus 0 times 2/4 plus 5 times 1/4. And that means we will get an average of about 3.75 points. So you'll get anywhere between 0 all the way to 10. So this game, technically, you're likely to gain points more so than you are to lose points. Okay? Or to not earn points anyways. You're not going to lose points. All right, number 6. It says a dice game involves rolling 2 dice. If you roll a 2, 3, 4, 10, 11, 12, you win $5. If you roll a 5, 6, 7, 8, or 9, you lose $5. Find the expected value you win or lose per game. So what this is, when it's talking about rolling 2 dice, that means it's talking about the sum of the dice. All right, so what I like to do when I'm talking about the sum, because I can't think of those answers right off the top of my head, is I like to make a table. Okay, so for my first dice, you have the options of getting 1 through 6. So 1, 2, 3, 4, 5, and 6. With your second dice, again, you have the option of getting 1 through 6. Again, 2, 3, 4, 5, 6. All right, and we'll just find the sum of each one of these. We're actually really quick to do that. Okay, 1 plus 1 obviously is 1, or 2, sorry. 2, 3, 4, 5, 6, 7. Because 1 plus 1, 1 plus 2, 1 plus 3, and so on. So that means it's going to be the same down this column. 2, 3, 4, 5, 6, 7. All right, then I'm going to keep on doing it. 2 plus 2 is 4, and then 5, and then 6, and then 7, and then 8. 3, 4, 5, 6, 7, 8. 3 plus 3 is 6, 7, 8, 9, because we're only going up 1 every time, so that means that our sum should go up 1. And then 4, 5, 6, 7, 8, 9. So that means that these should be 8, 9, 10, 9 and 10, and then 10 and 11. And then our last one would be 12. And that makes sense because 6 plus 6 is 12. Now, using common sense, 6 by 6 means that I have 36 different possibilities for my sums. All right? So that's what our bottom number of all of our fractions are going to be. So let's look and see what's the possibility of making some money. All right, if you get a 2, 3, 4, 10, 11, or 12, you win $5. So that means it's going to be a positive 5. All right, 2 happens only one time. So that's 1 out of 36. 3 happens, and I'm going to put a 5 outside of each one because no matter what, if any of these, I'm going to get a $5 bill. All right, if I get a 3, so 3 happens twice, so that'll be 2 out of 36. Plus 5 again. 4 happens 1, 2, 3 times. So that's 3 out of 36. And then 4 happen, nope, 2, 3, 4, 10 happens 1, 2, 3 times. So that's going to be plus 5 times 3 out of 36 again. Okay. 11 happens 2 times, so that's 5 times 1 out of 36. And then 12 happens 1 time, so plus 5 times 1 out of 36. Okay? Now, if we roll a 5, 6, 7, 8, or 9, that means we lose $5. That means it's going to be a minus 5 for all of those. So minus 5. If I roll a 5, that's 1, 2, 3, 4 chances that could happen. Okay? So 4 out of 36. Minus 5 again. If I get a 6, so that happens 1, 2, 3, 4, 5. So 5 out of 36. If I get a 7, that happens 1, 2, 3, 4, 5, 6 times. So minus 5 times 1, 2, 3, 4, 5. Yeah, 6 out of 36. Okay, minus 5. If I get an 8, 8 happens 1, 2, 3, 4, 5 times, so 5 out of 36. And then the last one, 9 happens 1, 2, 3, 4 times, so minus 5 times 4 over 36. So what I did is all of my options for 2, 3, 4, 10, 11, 12, all of those, I gained $5. Okay, if I roll a 5, 6, 7, 8, or 9, I lose $5. And a way to check to make sure your fractions are right is that all of these numbers on top should add to the number on bottom. So 1 plus 2 plus 3 and so on and so forth should add up to 36 because you should have 36 total possibilities of happening. Okay? So we just type all that into our calculator. 5 times 1 out of 36 plus 5 times 2 out of 36 plus 5 times 3 out of 36 plus 5 times 3 out of 36 again, plus 5 times 1 out of 36, wait, 11 and 12, that should be 2 out of 36, sorry, 2 out of 36, plus 5 times 1 out of 36. And then we start with our subtraction. So minus 5 times 4 out of 36. Minus 5 times 5 out of 36. Minus 5 times 6 out of 36. Minus 5 times 5 out of 36. Minus 5 times 4 out of 36. And that gives me negative $1.67. So I will actually lose $1.67 if I play that game, most likely. Okay, and again, there's a chance of always winning or whatever, but the likelihood is most likely that you will lose money. Because if you notice, 7 happens more often, so that's more likely for you to lose $5. So that's what it's basically taking into account, is the amount of possibilities that could happen. All right. Now, number 7 tells us to construct a counting tree to list the possible outcomes of a 3-child family. Verify that the expected value of having 0, 1, 2, or 3 boys is 1.5. All right. So what we're talking about is we're talking about how many boys we would have in a family. So we can start with all boys. And the order comes in, it matters here too. So that means you have to list out the girls in different orders too. So we could have a boy, boy, girl. We could have a boy, girl, boy. Or girl and then 2 boys. Okay. Then we could have 2 girls in the family. So we could have a boy and 2 girls. We could have a girl, a boy, and then a girl. That's how my family is. And then you could have 2 girls and then a boy. And then you can just have all 3 girls. Girl, girl, girl. All right, so that's 1, 2, 3, 4, 5, 6, 7, 8 different possibilities of it happening. All right, so of having 0, okay, 0 boys. That's only 1 out of 8 chances because all girls is 1 out of 8. All right, for 1 boy. All right, let me cancel that one out. 1 boy is 1, 2, 3 possibilities. So 3 out of 8. 2 boys is 1, 2, 3 possibilities. So plus 2 times 3 out of 8. And then all boys is 1 out of 8. Okay? So again, 1, 2, 3, 4, 5, 6, 7, 8. So that's how I know that my fractions are correct, because it should add up to 8 over 8 on top. All right, so we put our fractions in. 0 times 1 over 8. Oops. Plus 1 times 3 over 8. Plus 2 times 3 over 8. Plus 3 times 1 over 8. And that gives us 1.5. So we know that works, okay? All it did was ask us to verify that that's the possibility of it happening. All right, so that's how you find out expected outcome. And again, remember, fairness means that our possibility of winning is basically at 0, because that means you have an equal chance of either getting negative money or positive money. And if you get anything greater, then that's more than fair, because it's leaning towards your options. So then for your classwork, you're going to, again, go through some practice problems on what to do here. Make sure you read the problems carefully, all right? And you have all the way up to number 5, and that's all of your questions that you need. All right, and so that's it for day 8. That's the last thing we had to learn. So then you're just going on next to the study guide, and that'll be the last video for this unit. All right, miss you guys. Hate that we're not going to get to see each other anymore as a class, but I do hope we get to have graduation so I can see you guys one more time. All right, bye.